In previous sessions, we talked about encapsulation. In regards to layer 4, what would go in this area here? Some type of header. And more than likely, it's going to be either the UDP header or the TCP header, which looks like that, right? Okay. Which of these headers is considered reliable? TCP. And why is the TCP header reliable in comparison to UDP?
It's got a way of verifying delivery.
It's got a way of verifying delivery. Okay. All right. Well, when we look at the UDP header and get below the header here and look at the data field, what is this data? It's basically going to be the session layer header, the presentation layer header, application layer header, and the original data. Okay? So when we look at the UDP header and the UDP data, or the TCP header and the TCP data, that data is basically all of the headers and data of the upper layers. Okay? So let's turn our attention now to layer 3, which is the essence of chapter 5. And I'm going to go ahead and log into the Academy site. I'm going to access the class. You all should go ahead and do the same. And next, I'll select Network Fundamentals version 4, which is the online equivalent of your textbook, but it's more interactive. I'm going to go into chapter 5.
Some of the test questions came out on recognized.
Some of the test questions came from the online module.
Mine to be specifically the same thing.
Right. And what I recommend to students, if you have the time to read the textbook and experience the online module. Okay. 3, we basically have an option of IPv4 or IPv6. Okay, although the slide mentions IPX and AppleTalk, those protocols are basically not used on the internet anymore. All right, IPv4 is considered connectionless and best effort, and that's similar to some other protocol that operates at layer 4. It's similar to UDP. So if IP is connectionless, meaning that it just fires off the packets without any assurance of reliability, then how will drop packets be resent?
And the received numbers don't match, request for received.
Okay. IP operates at layer 3, right? And routers operate at layer 3. So in essence, if a router receives a packet and drops the packet, how will the end device know that the packet needs to be resent? That's going to have to occur at layer 4. That's if you're using TCP. If you're using UDP at layer 4, then you're going to be faced with the same problem of missing that packet. Okay. IP is also media independent. That means that you can use IP to transfer data over copper cables such as Ethernet, over wireless signals such as 802.11, and over fiber cables. This is what an IP or IPv4 header looks like in terms of the OSI model and encapsulation. the header information will go in this area. Okay? Let me ask you this. What's going in the source and destination address fields? Source and destination address fields.
Destination will be on your IP address.
Destination will be,
Source is your destination.
source is yours. The source is the quarterback, the destination is the receiver, right?
So they're talking about the website.
Right, it could be any other device, but it's going to be an IP address. All right? Now, in terms of layer 4, what addresses go into these two fields? No IP address. Port addresses, okay? When we couple a port address to an IP address, we refer to the combination as a what? Not a ratchet, not a wrench, but a socket. Socket. Everything all right? Let's take a look at this graph. Okay, we see the IP header, and then we see the data field. What's going to be in the data field? What's going into the data field?
The information.
Excuse me? Say it again, EJ. All the information from the upper layers. All the information from the upper layers. So we could say it's the original data, the application header, presentation header, session header, and the transport layer header information. Good job, EJ. All right. At layer 3, we can separate devices according to geography, purpose, or ownership. Why would we want to segment devices? What's the purpose of segmenting of devices? If we had, let's say we have 5,000 computers in our organization, why would we want to put them in categories or segments?
Would it make it easier for the information?
Okay, it allows us to manage the bandwidth. Okay, anyone else? EJ?
Keep them all on the same.
Well, actually, when we segment, we're going to put them on different networks. David? Well, we want to segment the computers. Why would we want to create a separate network? Keith? Oh yeah, it helps in terms of security because you can limit access to certain sections. You can grant more rights to certain sections based on IP addresses. Okay.
Makes administration of the network easier.
Makes administration of the network easier, especially in terms of isolating problems. You know, for example, if you're experiencing a problem in one section and that section has 15 computers, then you know you have to be concerned with 15 computers opposed to 5,000. Okay? Yes.
You say different networks. Will these networks?
The question is, will each different network have a different gateway?
Mm-hmm.
Yes.
Okay, it'll make it easier on the default gateway.
Makes it easier on the default gateway.
You're trying to handle 5,000. All certain at the same time.
Yeah, that's an interesting point. Yeah. Not hogging bandwidth. Yeah. Right, right. We're not overtaxing one default gateway. Good point, Jay. Yeah. Will. All right, let's go ahead and do this packet tracer activity. All you have to do is click this icon, this large icon, and when you do so, the packet tracer file will automatically open in Packet Tracer. Okay. If you don't have it, that's okay. We'll move forward. Just watch the big screen. You'll be okay. All right, we're going to go to simulation mode. And we're going to send a packet from PC 0. But before we send it, let's take a look at the packet and see what's going on there. Look at the layer 3 destination address. The layer 3 destination address is 255.255.255.255. What's going on there, David? Note the destination address, okay? Especially at a layer 2. The layer 2 destination address is all Fs. That's a broadcast address. That means it's going to go to every device that's on the local area network. The layer 2 broadcast address, which is all Fs, is the equivalent of the layer 3 broadcast address, which is 255.255.255.255. Okay? All right. Let's go ahead and send in the packet to see exactly where it's going. All right, I'm going to click the capture forward button. The packet is now at the switch, and it leaves the switch and goes through all the other interfaces connected to the switch. All right, I'm going to click the capture forward button again. It goes to the third switch. The broadcast goes from the third switch to all the other PCs. Well, Will brought up an interesting point. That's about how a virus could spread. Yep. Instructions want us to reset the simulation and go to scenario 1. All right, scenario 1, the packet is going to be sent from PC 6. Let's look at the destination address. Again, the layer 3 destination address is 255.255.255.255, which is the broadcast. And the equivalent at layer 2 is all Fs, which is the broadcast. Okay. All right. The